Welcome back for lesson 3.1, part 2. We are going to look at some examples using all of the vocabulary and definitions that we just went over. So let's take a look at those. Get out your notes here. First example says the sample space S is the whole number starting at 1 and less than 20. Okay, so our sample space is going to be denoted by, it's always in brackets, the squiggly brackets, they're fun to draw. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through 20. 11, 12, 13, 14, 15, 16, 17, 18, 19. And because it says less than 20, we are not including 20. That's important to note. Let A be the event of the even numbers and B numbers greater than 13. So the even numbers will be 2, 4, 6, 8, 10, 12, 14, 16, and 18. And B are going to be numbers greater than 13. So greater than 13 means we're not including 13. So that would be 14 through 19. C says, what is the probability of A? So the probability of A is the number in A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of all of the numbers in our sample space S, and there were 19 because it was 1 through 19. And that can't be reduced. And usually in probabilities, for the most part, you can leave them unreduced because then we know exactly what our original sample space was. The probability of B is the number in B, 1, 2, 3, 4, 5, 6, out of the number in S. D says, what is the probability of A and B? So A and B means they have to be in both. So let's mark with a red pen all of those that are in both. So it looks like 14, 16, and 18. 14, 16, and 18 are the three that are in both. And then D is, well, actually, sorry. Down here, we want to find the probability of A, which would be 3 out of 19. So D, we just want to list them. So 14, 16, and 18 are in both. That's what we wanted to do. A or B is we just want to list the ones that are in A or B. So A or B would be 2, 4, 6, 8, 10, 12, and now 14 only gets listed once, even though it's in both. 15, and then 16 only gets listed once. 17, 18 only gets listed once, and 19. 19. This is an accident over here. The probability of A or B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 19. F says, what is the sample space for A prime? So A prime is anything not in A. Okay, so all the values that are not in A. So it looks like all of the odds, right? Not in A would be all of the odds. That'd be 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. And so the probability of A prime would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 19. Or we could do 1 minus the probability of A, because that should also equal A prime. And that would be 1 minus A, which would be 19 over 19 minus 9 over 19, which would also get us 10 over 19. And what is the probability of A plus the probability of A prime? So that would be 9 over 19 plus 10 over 19 is 19 over 19 or 1, just like we thought. And that says, what is the probability of A given B? And what is the probability of B given A? So the probability of A given B means what is the probability of A and B divided by, make sure we go back to the definition. The probability of A given B is the probability of A and B divided by the probability of B. So A and B, we already said, the probability of A and B is 3 over 19. And this is why it's good not to reduce the original probabilities, just because it makes it a little bit easier. Divided by the probability of B, which is 6 over 19, which gives us 3 over 19 times 19 over 6, which gives us 3/6 or 1/2. But you can just keep the 3/6. That's this one right here. Okay. Now, so this is 3 over 6. Now the probability of B given A is also the probability of A and B in the numerator, but this time it's divided by the probability of A. So again, we start with 3 over 19. And the probability of A is 9 over 19. And so this would be 3 over 19 times 19 over 9. So we end up with 3/9. And so the answers, are the probabilities equal? No, they are not equal. Not even close. Let's try another one. Let's have you try this one. So it says the sample space S is all the ordered pairs of the two whole numbers, the first from 1 to 3 and the second from 1 to 4. Okay, this one is tricky. So S is all the ordered pairs. Okay, from 1 to 3 and then 1 to 4. So we've got the ordered pairs of 1, 1, and then 1 and 2, and then 1 and 3, and then 1 and 4. And then we've got 2 and 1, 2 and 2, 2 and 3, and 2 and 4. And then we've got 3 and 1, 3 and 2, 3 and 3, and 3 and 4. So there were 3 possibles for the first one, 1, 2, and 3, and 4 possibles for the second one, 1, 2, 3, and 4. So there should be 12. Let A be the even numbers, and B the greater numbers greater than 13. I mistyped that. That is a typo. It'll be corrected on yours. The first number is prime. It should be this. I don't know why I wrote that. Okay, so what is an A? The even numbers. I'm sorry, the sum is even. This should be the sum is even. So if we add 1 and 1, we get even. So that's 1 and 1. Not 1 and 2, 1 and 3 is even. Not 1 and 4, 2 and 1 is not even, 2 and 2. Not 2 and 3, but 2 and 4. 3 and 1 is even. That makes 4. Not 3 and 2, 3 and 3. 3 and 4, no. And B is the first number is prime. So that would be all of the ones, because 1 is prime, meaning it has no factors other than 1 itself. All of the 2 is even, so it's not prime, and then all the 3s are included because 3 is a prime number. You have to think about that a little bit here. So there are 12 in S. It says the probability of A. So how many outcomes are in A? 1, 2, 3, 4, 5, 6. So 6 out of the 12. And what about B? There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 out of the 12. What outcomes are in A and B? Okay, so 1, 1 are in both. They have to be in both. 1, 3 is in both. And it looks like 3 and 1 and 3 and 3 are in both. And then what are the outcomes that are in either of them? Okay, so 1, 1 only needs to be counted once because it's in both. 1, 2, and then 1, 3, 1, 4. 2, 2, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4. Okay. What is the probability of A and B then? So there were 4 outcomes that were in both. 1, 2, 3, 4 out of the 12. The probability of A or B would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of the 12. What ones are not in A? Okay, so not in A would be the 1, 2, the ones that added up to be odd, right? The 1 and 4, 2 and 1, 2 and 3, 3 and 2, and 3 and 4. The probability of A would be 1, 2, 3, 4, 5, 6. And we can see that the probability of A is 6 out of 12, plus the probability of A prime is 6 out of 12. So we indeed get 1. And then it says, let's calculate the probability of A given B. Is going to be the probability of A and B divided by the probability of B. The probability of A and B up here is 4 out of 12. divided by the probability of B, which is 8 out of 12. And that gets us to 4 out of 8. And then the probability of B given A, again, is the probability of A and B divided by the probability of A this time. This would be the 4 out of 12 divided by the probability of A, which would be 6 out of 12. So that is 4, 6, and no, they are not equal. A fair six-sided die is ruled. Describe the sample space, identify each of the following events with a subset of S, and compute its probability. An outcome is a number of dots that show up. Okay. So we're rolling a six-sided die. Event T is, the outcome is 2. And so that would be, T is defined as a 2. And the probability of T is 1 out of 6 times it could be a 2. Event A is the outcome is an even number. So A would be a 2, a 4, or a 6. And the probability of A would be 3 out of the 6 sides. C would be the event, the outcome is less than 4. So B is a 1, a 2, or a 3, because strictly less than 4. So probability of B is also 3 out of 6. The complement of A would be the probability of A prime. So that would be not an even number. So we could do just 1 minus the probability of A. That's just as easy. 1 minus 3 out of 6, which would be 3 out of 6. A given B is the probability of A given B. And that is probability of A and B divided by the probability of B. The probability of A and B, they have to be an A and B. So 2 out of the 6, sorry, 1 out of the 6, it's just the number 2. Divided by the probability of B, which would be 3, 6. So 1/3. And the probability of B given A is the probability of A and B divided by the probability of A this time. So 1/6 is where they're in both. And the probability of A is also 3, 6. So it's also 1/3. So these do happen to be the same. That's just something. A and B is the probability of A and B, which we said was 1/6. And the probability of A or B is anything that's an A or B. So we've got 1, 2. So this one is, let's do the probability of A plus the probability of B, right? But we have to subtract away the overlap, because if we couldn't just count them, we would have to know that there's some overlap here. So the probability of A is 3, 6, plus the probability of B is 3, 6. But we have to subtract the fact that 2 occurs in both, so 1/6. So 5/6 of the time, it's in one or the other. A or B prime. So the probability of A or B prime is in A or not in B. So not in B, not in B would be 4, 5, and 6, right? 4, 5, and 6. A or not in B. So that means that we have a probability of A plus the probability of B prime minus the overlap. So A is 3, 6 plus B prime is also 3, 6. But we have to subtract the fact that 4 and 6 are both in A and B prime. So 2, 6 we have to subtract this time. So we end up with 4, 6. Event N is the outcome is a prime number. So the probability of N. So the outcome is a prime number would be 1, 3, and 5. So N is 1, 3, and 5. So 3 out of the 6. And event I is the outcome is 7. Can't happen. There you go. Our next example here is a table. It says the table describes a distribution of a random sample S of 100 individuals organized by gender and whether they are right or left-handed. So the right-handed, left-handed, males and females. Let's denote the events M. The subject is male, F is the subject is female, R is the subject is right-handed, and L is the subject is left-handed. Compute the following probabilities. The probability that it's male would be all of the males. So that would be 52. Remember, there are 48 females. So there's a total of 100 altogether. So the probability that it's male is 52 over 100. The probability that they're female is 48 over 100. Okay, and we need to do a total this way as well. Probability that they're right-handed, there's 87 out of the 100 that are right-handed, and there are only 13 out of the 100 that are left-handed. The probability that you're male and right-handed. So we can actually just look at those. So they're in the males and they're right-handed. So it has to happen in both. So that would be 43 of them were males and right-handed. Females and left-handed is 4 out of the 100. Male or female. Well, that would be everybody, right? Which would be 52 plus 48. So that's 100 out of the 100. Male or right-handed. Okay, so male would be 52. So let's write this out. This is going to be the probability of the male plus the probability of being right-handed minus the probability of any overlap, because we can see that there is males that are also right-handed. So we would have 43 is the males plus the right-handed. I'm sorry, the males are 52. The right-handed people are 87. And then we're going to subtract the 43 that is overlap. So we have 139. So 52 plus 87 is 139 minus the 43. So we have 96 out of the 100 are either male or right-handed. For female or left-handed, so the probability of a female plus the probability of being left-handed minus the probability of the overlap. So the probability of being female is 48 plus the left-handed people are 13. And then if you look up, being left-handed and female is going to be this bottom cell right here, 4. So we have to subtract the 4. So that is 48 plus the 13 minus the 4 is 57 out of the 100. What about the probability of M prime? So not a male. So we could do 1 minus the probability of being a male. That's so the probability of being a male is 52 over 100. So not a male is 48. What about the probability of R given M? So that would be the probability of R and M divided by the probability of M. So R and M, we did that up here, 43. Divided by the probability of M, which is 52, which is 43 out of 52. What about the probability of F female given you're left-handed? So that means the probability of female and left-handed divided by the probability of being left-handed. Female and left-handed was 4 out of 100 divided by just being left-handed is 13 out of the 100. So 4 out of the 13. What about the probability of being left-handed given that you're female? Okay, so that's also going to be the probability of F and L divided by the probability of F. So that is also going to be 4 out of 100 divided by the probability of female, which is 48 out of 100. So 4 out of 48. And you could turn these into a decimal and then a percent if you like to talk about them as 8.3% of the time of the females, they will be left-handed. So that's one other way to do that. We can also look at pie charts. So these are hard to see the colors. So I'm going to skip this for now because I wanted to get these in color for you all. I'll get to that. So this is a blue and a blue. You can kind of tell by the shading. This is red and red and red and red. And then this is yellow and this is green. So let's just do their probabilities. There's 1, 2, 3, 4, 5, 6, 7, 8 outcomes. And the blues have 2 of the 8. And the reds have 4 of the 8. The greens have 1 of the 8 and the yellows have 1 of the 8. And if we add them, we would have 8 out of the 8. So if you land on what? It says you see a game at a local fair, you have to throw a dart at a color wheel. A says if you land on yellow, you got the biggest prize. So the probability of Y is a 1 out of 8. If you land on red, you don't get a prize. And the probability of red, we said, was 4 out of 8. And that concludes the last part of lesson 3.1, our introduction to some basic probabilities. And catch me back for 3.2.